Welcome to another GCBASIC demonstration. This is part 4 for the legacy chips 16F, but you can use the same program on a 10F or 12F, but it's legacy. So what we're going to do is sequence the LEDs. We've seen the LEDs being controlled before with time, but we're going to advance that to what's called sequencing, and we're going to introduce some fantastic GCBASIC capabilities. Like and subscribe to this video. Please let this video run all the way through. Please, those metrics are extremely important. So let's get into part 4. GCBASIC is an open source compiler, so what I'm showing you is specific to the 16F, but you can do the same in an AVR or LGT, an advanced chip. You just need to change some of the settings as we get deeper into this video set. This is for the 16F, as I've said previously. Same applies for 10F or 12F. So I am assuming you've installed the GCBASIC software. You have an IDE or editor working. That you've installed some programming software. You've tested the PIC your 4 LEDs and a pot, because that's what we're going to be using. Now I'm using this board. It's a PIC-Dem2 Plus demonstration board. I will press the default on there. There we go. And I'm going to show you it live on my desk cam. Here's desk cam. Bit darker today. That's because it allows us to see the LEDs. As you can see, the LEDs are flashing now, and you can see them a lot better than we could previously. But this board has a fantastic amount of capability, and we're going to see that be developed as we move through. So it's got clocks and timers. It's got different chips. It can take 18s, 28, 40s, sound, prototype. So cheap. They're on the second-hand market. Go get one. Hardware-wise, we're going to be using analog 0, and that is on port A0 and the 4 LEDs. From a circuit standpoint, RA0 is connected via a 1K resistor to the 10K pot and a capacitor. So if we go back to the camera, we can actually see some of this. Here we go. Let me just zoom that. And you can see quite clearly that they all say RB0, RB1, RB2, RB3, and RA0 is there. So we can see on this little thing here, on that little camera shot here, we've got them operating. However, from a documentation standpoint, you'll see this in the program so that you just know what we're using. You'll also see there's reset or master clear, which we'll be using later on in the video sets. I've put that there just so I know where it is when I'm working on it. So this tutorial, it builds upon the previous tutorial of the ADC or analog digital converter, but this time we're going to change the way we use the weight. Remember, weight was a unit, a time, and a unit, a value of time and a unit of time, like wait 1 millisecond. And so what we're going to do is get GCBASIC to initialize the chip for us. We're going to create a variable to store the ADC, read the ADC, and we're going to use a 10-bit read AD10, and that's returning a value of 0 to 123. Then we're going to set the time period based upon the value returned in the ADC variable, and set the LEDs and do it all again. The problem is, of course, is that you might get a 0 value back, but we'll address that in a moment. And so we have a flow chart. It looks like this. Initialize the LED, set the first LED, read the ADC10, wait for a delay, rotate. Wonder what rotate is. We'll talk about rotate very shortly, because we're going to test to see what happens when we've rotated. And rotate is a very useful command. If it did not overflow, go back, do another read, wait for a delay, rotate the LEDs until it does overflow. And when it does overflow, go back and set the first LED, because it looks like this. What happens is we're going to set LED 3, then 2, then 1, then LED 0. And when the carry is set, we go back and set LED as the first LED, LED 3. Looks like this. Set, rotate, set the next one. Rotate, and it's moving it. Essentially, what it's actually doing is doing divide by 2, but it's not. Mathematically, it's divide by 2, but it's just rotating the bit. And if you look at the file register up the top right-hand corner, if I go back, you can see that the file register is also moving along. Set bit 0. And when I rotate the next time, it puts it in the carry, and I can test for carry. I can say, is the carry equal to 1? Because the only time is when it carries it. And then I can restart the process and carry on infinitum. So we can use carry or C in GCBASIC, and C is consistent across the PICs, the LGTs, and the AVRs. So use C rather than, for those who might know it, it might be called status register, status reg.0, lots of different names for it, but GCBASIC uses C to keep it portable. Because if the carry did overflow, or C equals 1, then we can restart the process. So we'll see that. The other thing we're going to do is scale the results of the ADC. I'm going to do that so that we can set a minimum value and a maximum value. Whilst we're getting a 10-bit returned value, we're using scale just to show that you can transform any number to another number within a specific range. So ADC 10 comes back as 0 to 1023. In this case, we're going to set it to a minimum of 30 and a maximum of 500, because we are going to use that value for the delay. So let's do some coding. I'll show you my desktop by pressing the Windows key. GCS should offer you GCStudio. Press enter and it will open up GCStudio. I'll zoom in for you. I'm going to take this third thing down that says microchip PICDEM2 plus board 2010, because that's where we have all our folders. That's where the files are. Click select it. Go back to full screen. And now we've got a program. That's the one we're going to be using. And then we've got all our files on the left-hand side. But if they weren't there, press on that bottom window. We'll say open like that. You can go Control B, and that will open it. You can also press top right-hand corner of a little Explorer icon. It's the same. Open up program 60. But I've got lots of 60s. Like, oh, look at this. What a pain. I'll show you. GCB is our source file. Let's click on that, and we have opened up that particular file. Let's clean that folder up. I'll show you something you can do. Once you've got a GCB file open, function key F4, you can type in the word clean, and it will clean the folder, and it will get rid of all the files that you don't need, like all the list files and all the other files that the compiler creates. Now we've only got GCB source files, which is great. We've got the one we need. Variable rotate with LEDs, number 60. Let me shut down that window, Control B and Control J to turn off the terminal window. So let's look at our program. Anything in green is in comments. You can read it on your own. I specified my chip. It's I'll zoom in for you. 16F 1937. I took a random chip to do this set of demos. Option explicit means I have to define my variables. This is my port diagram. I showed you that previously. In the previous videos, and this is the last time I'm really going to mention, I've started to create a series of constants to the ports for the LEDs. So I can then use this program elsewhere. And trust me, I do. I've also defined an LED port. The whole port of lat B could be port B. GCBASIC is figures out which what to use anyway. It's fully automatic. Let's turn that to port B. It'll be the same, just for clarity. And then I defined a constant for the potentiometer. So we'll only discuss the ones that I'm going to add in the future. Now we're into our real program here. Look, main program commences. Everything before that is the setup of the board. So I'm going to create a new type of variable called a word, and that word variable is called ADC val. I've created a byte variable called LED port state, and I'm going to put the representative values of the LEDs in that variable and then use that variable to set the whole port. Really quite clever. So the initial state is set here 10000, which basically means turn on the LED. And here we have our main loop, do loop. I read in ADC, read AD10 returns a 10-bit value into the variable ADC val. I scale it. Wow. So I give it my variable. I give it my range, that's on the input side, and then the range on the output side, which is 30 to 50, which is I want it to be 30 milliseconds to 500 milliseconds. So I've got a range that's bigger than my 8-bit value anyway. So I've got a range here of 470. So, but you can change that range and you can play with that yourselves. In actual fact, we'll change that to 100 milliseconds. Now we've brought the range down to 400. And I assign it back to our original variable. Do a wait. Now we've got a variable. And remember, the weight is calculated against the frequency of the chip. It's all calculated for you. All you have to do is pick your units. The code in red, I'll let you think about why that's there. It's a bit of a hangover. If you didn't have the scale, you would need. Try running this program without scale, and you'll need that. Clear the carry flag. Clear the carry flag. We spoke about the carry flag. Clear it first. Rotate. Rotate my variable to the right, which means move it, as we saw in that diagram previously, move the LED, the value of that LED to the right. It's effectively a division by 2. It moves it integer, so it will go from an 8 to a 4. Rotate. 4 to a 2. 2 to a 1. Rotate. 1 will become a 0, and the carry will flag, and the carry will be set. So if the carry has been set, reset our sequence by setting our variable back to 1. So I'm setting the third bit of that particular variable to on, because we already know that if the carry flag is empty, the whole of LED port state is already 0. So we just set the 1 bit we need to set. And then we set the port. We set the port here to LED port state plus what's called a mask. We just mask off any other values that have crept in. It's not needed because it cannot be any other value but the first 4 bits. But just good practice to show you. Pressing function key F5. That will compile our program and then we'll send it off to the chip. Let's look at what's going to happen out here. Now programming it. Assembled it. It's already programmed it. And in here, I can now rotate the potentiometer. The minimum is 100 milliseconds, which you can see. And the maximum, what did we set the maximum to? 500. And the reason I did that, bottom value of 100, by the way, is because, I want to put it so you can see the code, is because the camera didn't catch it at 30 milliseconds. So look, I can rotate that. What am I doing? Reading the ADC with a 10-bit value, scaling it to 100 milliseconds to 500 milliseconds. I'm rotating the LEDs and I'm testing the C. When it gets to the C, it puts it back to the beginning. You might need it a bit slower so you can see it. There we go. That's 500 milliseconds, half a second. Up, carry, reset. Carry, set, reset. It's carrying on forever. That's rotate the LEDs. Let's go back to PowerPoint. See if there's anything else I should be saying. No, I think that's it. Next video, we're going to use inputs, switches, and things like that to set the state of the LEDs. Enjoy.